So the first thing we want to look at, and like what you should always be on the lookout when you're trying to factor, whether you're solving a quadratic or if you're just trying to simplify an expression, is you always want to see, is there a greatest common factor? Is there something you can pull out from both or all of the terms? We call, like, when we have an expression, like we call like each part a term. Like 12k would be a term, minus 18 would be my second term. So if I ever use the word term, I'm talking about like just one piece of my equation, or in this case, these are all expressions because we don't have equal signs. But so to pull out a greatest common factor, you want to think of like the biggest number that would divide into both of them. So like, for example, like the greatest common factor between 12 and 18, um, usually you can kind of see it, like if you get good with these. You can always check too to see if, make sure you pulled out the biggest thing, but I see that 6 goes into both of those. So you could pull out a 6. Oops. So when you pull it out, like when you pull out a greatest common factor, you divide each one of your terms by the GCF or whatever you're pulling out. So like 12 divided by 6 would be 2k. 18 divided by 6 would be 3. So this would be my factored expression. And you could always check, like, I mean, if you distributed that 6, you would get back to where you started. And one thing you might want to do, especially if you're not super confident, like just double check, is there anything I could pull out from a 2 and a 3? Well, no, because those are called prime numbers. Like the only thing that divides into 2 or 3 is 1 in itself. So like there's nothing I could also pull out from it. So this would be our simplified form. Oops. So there's nothing else I could do. And we'll see, like once you get it in this factored form, you can solve your quadratics from here. But we'll worry about that when we actually start solving. But really like to solve quadratics, you're going to want to get it into this factor. You're going to want to factor it or get it in factored form. Let's look at number 2. So first thing you want to do is look at your constants. Like what's the biggest number that would divide into 40 and 64? Kind of depends on like how good you are with like your multiplication facts, but I see right away that 8 goes in, and I'm not sure if it's the biggest. Like I said, I can always check it at the end, but I know I can pull out an 8. So that's at least a good start. So I'm going to pull in an 8. We didn't see like with the variables last time, but you do want to look at your variables. Like, so we did our constants. Here, maybe I'll color code it. So we'll look at our x's next. I've got 8 x's and I have 4 x's. So what could I pull out from each one of those without pulling too much? Like, so I could pull out 4 x's, right? Because I can pull 4 x's out of 8, and I can pull 4 x's out of 4. I couldn't pull any more out, though. Like, I couldn't pull out an x to the 5th because the second term doesn't have that many. And then we'll check our y's. Well, they both have 1 y. So I could pull out a y. So like my GCF would be 8, or I'm just going to rewrite it because I got a little bit sloppy, but it was 8x to the 4th and a single y. So then we're really going to just divide by what we pulled out. So I mean, 40 divided by 8 would be 5. I pulled out 4 x's from 8, so there's 4 left over. And I pulled out 1 y from 1 y, so there's no y's left. So that's the first term. And then for my second one, 64 divided by 8 would be 8. I pulled out 4 x's from 4 x's, so they're gone. I pulled out 1 y from 1 y, so it's gone. So this would just be 8. And you could double check, like, is there anything I could pull out from what's inside here? I mean, 5 and 8 don't have any common factors. And there's no like common x between them either. And if you distributed, like if you don't believe me, if you don't have to do this, but if you did distribute, I mean, you would get 40x to the 8th y plus 64x to the 4th y. Like you would get back to where you started. You're basically undoing the distributive property. How about you guys try 3 and 4, see if you can pull out your GCF. One tip for number 4, you're not going to be able to pull out the constant. Like, so you'll only be pulling out like your variables in number 4. But give 3 and 4 a try, see if you're okay with this pulling out a GCF. Um, but you always, like, no matter what you're doing, you always want to see if there's a GCF, because if you can pull it out, it usually makes your life a little bit easier. Um, like it can turn one of our harder factoring problems into a simpler one. So it's always worth looking to see if you have a GCF between all your terms, because it can make your life easier. Oh, I'm sorry, I just saw in the chat. One sec. I have no idea what's going on. So like for number 3, you're gonna try and pull out like your biggest, like you're trying to pull out your greatest common factor. Like that's the biggest thing that would basically divide into both, like all of your terms, or like each piece. So for like 3, the first thing you want to think about, like what's the biggest number that would divide into 14, 35, and 7. So then you would write that on the outside, and then see how many m's you could take out from each part. So I don't know if that's helpful. One second. You should be able to pull out a variable in 3. Like you should be able to pull out some m's. In here, sorry, I was just grabbing my key. I don't tell anyone wrong. So sorry, I think I got everyone in this. And I'll be honest, like these questions here, like that we're pulling out our GCF, these ones are honestly probably worse than, like usually when you're looking at problems, honestly, usually you can only pull out like a constant, like you can pull out a 2, or maybe you can pull out an x. Like these ones have a lot going on. Like I said, like you'll see, like when we're actually getting into like problems where we're solving quadratics, like we won't be pulling out as like in number two we pulled out an 8, 4 x's and a y. Like it won't be nearly that involved. And I'll try and break these down maybe more if you're not still getting it. It's just hard with the space, but we could like break these down. Let's look at number 3. So some people that sent me your answers were looking good. Some small things too I was seeing from some people. For number 3, though, and sorry, I forgot to pause the video, so there was like a gap there while I let you guys work. If you do watch this soon later. So for, I mean, the first thing, like the biggest number you can pull out of 14, 35, and 7 is 7. So I'm going to leave a little bit of space because we're going to pull out some more stuff. But I mean, the first thing is if I divide all these parts by 7, I'm going to have a 2. I'm going to leave a little bit of space for like the m part. I'm going to have minus a 5. I'm going to leave a little bit of space for the m part. And then this would be a minus 1, and I'll leave a little bit of space for my m part. So that's how you do the constants, which most people I saw had this. But for our m's, like if you think about it, like this is 6 m's. Then we have minus 3 m's. Then we have minus 2 m's, like from like the m third, m6, m squared. So like if you think about what they have in common is like for like what you can pull out of each one. I can pull 2 out of this group. So I could pull 2 out of this group. I could pull 2 out of this group. I couldn't pull any more than 2 though. Like if I try to pull out 3, for example, I can't pull 3 out from that last group. Like you have to be able to pull, like for it to be a greatest common factor, that means you have to be able to do it for all of your pieces. So I can pull out 2m's. So that would be m squared. So if I, like for this first one, if I pulled out 2m's, I have 4m's left. If I pull 2m's from that second group, I only have 1 left. And for the last group, if I pull out 2m's, well, I don't have any left. So I just wouldn't put any m's. Oops, crap. This is trying to delete the underline, but this would be, oops, your answer. I was just trying to get rid of those underlines. But you would have 7m squared as your GCF. And then you would have 2m to the fourth minus 5m minus 1. I hope maybe how I wrote it here was maybe a little more helpful to kind of explain that. But basically, you're trying to see how many m's or like how many variables you can pull out from each part. But let me know if there are any questions for 3. Let's look at 4, and I'll zoom out if you need it. So for 4, let me just erase that. So you want to look at your constants. Is there anything you could pull out of a 3, a 5, and an 8? No, I mean, the only thing you could pull out is like a 1, but usually we're not going to pull out, like we're not going to write that. So there's really not anything I can pull out for my coefficient. So I mean, if you want, like, I don't know if it's helpful to do this, but we would just have a 3. I'll leave a little bit of space, minus 5, and plus 8. I'm gonna make sure I leave enough space. I'm just gonna leave a spot. I'm gonna just delete that. Oops. So we want to think about like, and if it's helpful, you could write it out long ways. I mean, you want to get to a point maybe where you don't need to do this, but we have an a and 2 b's for the first part, like ab squared, and then a squared b would be 2 a's and a b. Then we just have an a and a b. So we want to see like what can we circle, oh, not a plus, but just a times b. So I mean, like if you look at all 3 of these parts, you see that they all at least have 1 a and 1 b. So like that's what we could circle, an a and a b. So I'm going to pull out an a and a b from each one of these groups. So for my first part, I just have a single b left. For my second group, I just have a single a left. And then for my third group, well, I pulled them all out. So I don't have any variables parts left. So it would just be that 8. So like this would be my factored form. AB parentheses 3b minus 5a plus 8. And if you want, like if you distribute this, like you would get back to where you started. Like, so I mean, what we're doing, it's not changing the problem. We're just rewriting it in this factored form. We'll see if we're able to factor different, and it doesn't have to be quadratics. Like in chapter 5, we'll be looking at other types of polynomials. Like we'll look at like things with powers of 3 and all different types of powers. But if you can factor down your polynomial, it makes it much easier to solve. And this will be true for like all your future math classes. If you end up taking calculus level courses, if you're able to factor your problem down, you're going to make your life so much easier. Or like problems that at first might seem impossible, once you factor them down or make them simpler, you'll be able to solve. But you will be practicing it. So when you're factoring though, the first thing you always want to check, is there a GCF you can pull out? Like no matter like if you're factoring or you're trying to solve like a quadratic, like which we'll be doing a lot in chapter 2. Like your first thing you should always look, is there anything I can pull out for my GCF? Because if you can do that, it will make your life most likely easier. Like we're going to see there's a lot of different methods we're going to learn. Sometimes if you pull out a GCF, it'll make it one of the easier methods instead of one of the more complicated. Like maybe instead of doing quadratic formula, if you pull out a GCF, you might just be able to factor it like a basic trinomial. So that's kind of like our first method, or kind of like our first way we can factor uh, quadratic. And like after your factor, you always want to check like, well, can I factor this down anymore kind of thing. Sometimes you can, sometimes you can't. So we'll kind of see when we get into bigger problems. But let's look at our second type of factoring that I want to make sure we review. And this is how to factor a trinomial. A trinomial, just so you know, that's a polynomial, or like an expression that has 3 parts. So we have an x squared part, an x part, and a constant. So that's why we call it a trinomial, triangle, 3. So there's 3 parts. That's all trinomial means, though. Binomial, like we said, is like a 2-part thing. So like bi, like bicycle, 2 wheels, bi means 2. So to break down a trinomial where your and it's really crucial, if your coefficient is 1, your life's a lot easier. We'll see like our next set is if you don't have a coefficient of 1, but I know 11 and 12 don't, but we'll see why they're in this section in a second. So to factor a trinomial, and I don't know how your teachers wrote it. I'll try and write it like this. Let me know if this looks familiar or not. But this is where you have like your A, B, and C. To factor a trinomial, you want to come up with a number that multiplies to your C. Okay, let me zoom in so I can write this a little bit more. So you're always going to try and, I usually write it with like a tree. Some of your teachers might use an X. I don't do it, so I'm not going to do it. So you want to come up with a number that multiplies the C and it adds to your B. So that, like, this is what you always be doing. So like in this problem, our C is 45 and our B is 15. So try and think of 2 numbers that would multiply to 45 and add up to 15. Some people just like to list them out. Like, so for example, what multiplies to 45? 5 and 9, right? No, not 5 and 9. Oh, is that right? Like going completely blank. 8 times 5. Yeah, that would be right, right? What else multiplies to 45? You could do 15 and 3. What else multiplies to 45? I think that's it. At least that I'm thinking. I mean, obviously 45 and 1. Yeah, don't forget. You can always do it, the number in itself. But which one of these pairs of numbers would add up? And I wrote the wrong number. It's not 15. That's why I was kind of wondering. I was like, that's not going to work. The B, was 14. There, it wasn't 15. So which one of these would add up to 14? Well, it would be this pair. So when we write our answer, like it would be, since those are both positive factors, it would be x plus 5, x plus 9. I'm going to erase this really quick. Some of your teachers, let me know if this looks more familiar too. When you factored in algebra 1, some teachers do like this big X. They put their C on the top. They put their B on the bottom. Oops, which was 14. So then usually they would just write like their factors here, like which one of these multiplies to the top and adds to the bottom. I don't know if that looks more familiar. Some teachers draw like this X to kind of organize your work. So if that is more comfortable, let me know in the chat. I'll write it like that. But let's go to a new problem. Let's just see some more. So this one, like remember, you want to come up with a number that multiplies to your C, so 26. So we want it to multiply to that number. We want it to add to our B, which in this problem, just be careful since it's minus, that would be a negative 15. So we'll have to mess with our signs a little bit. So usually I just try and think of two numbers that multiply the 26, and then I mess with the sign. So just remember, to get a positive number, you can have a positive and a positive, or a negative and a negative. But I see in the chat someone sent me, it's going to be -13 and -2. But there's some tips with the signs, like if your C is positive, well, your signs are either going to be positive and positive, or negative and negative. So if you want it to add up to a negative number, obviously they're both going to be negative. But through a little bit of trial and error, you should eventually get it. But this would be, since we got negatives, it would be W minus 13, W minus 2. But good. And I hope this doesn't seem like this isn't completely new. I mean, I know it's been a bit, because you guys definitely weren't factoring in geometry, but you should have done this in Algebra 1, at least a little bit. For this problem, we want to think of something that multiplies to -48 and adds up to +2. So, I mean, sometimes it can be a little bit tough. Like if you're struggling with this, there, like when we learn more methods, eventually we'll have like a backup plan. So even if it sometimes it's not possible too. Like there are cases where like this won't always work, but you definitely want to take the time to check if you can do it this way, because if not, you're going to have to either complete the square or do something called quadratic formula. So it can be a little bit tedious. But just for sake of time, like 48, for example, would be 8 times 6, but we got to mess with our signs, because the only way to multiply and get a negative number is one of them has to be positive, one of them has to be negative. So you can mess with your signs a little bit. I mean, but if you wanted to add up the +2, you would make the 6 negative. So this would be C plus 8, C minus 6. 24 and -2 would have like been mathematically correct for the multiplying part, but that wouldn't add to +2. So you'd want to try a different pair. Like it has to meet both of these requirements. It has to multiply the -48 and add to 2. So sometimes it's a little bit of trial and error. Like you might not get the right pair of numbers like your first time all the time. But hopefully that makes sense, like why you wouldn't be able to use that. But you are correct, like that would be something to check. How about you guys try, I don't know, 8, 9, and 10? We'll talk about 11 and 12. But this is where we're gonna get, like once we finish this, I'm gonna cut it off. We'll look at the other sections tomorrow. So for number 8, you would want to think of a number that multiplies to -72. And you don't have to like write this multiplying it out. I'm just putting it just to make sure we remember. Usually like once you do it, you don't. And we want it to add up to -1. So you always multiply to your C, add up to your B. So what would multiply the -72 and add up to -1? So like I said, especially if you're like, if this is where you're having some issues, just try and think of numbers that multiply to +72. So like 9 and 8. I don't know what else would. 2 and what's half of 72 would be 36. I'm sure there's others. 4 and something would go in. What would it be? 4 and 18. So I'm sure there's others too, perhaps. I think 3 would go in as well. But you want it to add up to -1. So like one key is to multiply to a negative number. One of your signs needs to be positive, one of them needs to be negative. So you want to look at these pairs and see which one could have a difference of 1. So, I mean, 4 and 18 are 2 spread out. 2 and 36 are 2 spread out. 3 and I think, I don't know what it would be. 3 and something would work as well. 3 and, I don't know. I don't want to mess up on the top of my head, but 3 and 24 maybe? Yeah, theme 24, but that would be 2 spread out too. So 9 and 8 is the only one that's going to be able to have a difference of -1. So we want to think about which sign do I want to make negative. So to get -1, you would want to make the -9 your negative number, because -9 plus 8 would be -1. So this would be n minus 9 times n plus 8. Okay. And sorry, just for space, I'm gonna have to erase part of that. So for 9, what would multiply to 36 and add up to 12? So maybe you notice this one, 6 and 6, or it's actually one of those perfect square trinomials like when we were completing the square. So this would be a plus 6, a plus 6, or you could write that as a plus 6 squared. So, and 10 is pretty similar. What would multiply to 1? Add up to -2. So, I mean, the only thing that multiplies to 1 is 1 and 1, or -1 and -1. So, and that's going to be our pair that meets both requirements. So you could just write it as n minus 1, or just n minus 1 squared, because it's the same factor. Okay, 11 and 12, same idea, except it, like I said, you always want to look for a GCF. If you look at number 11, you could pull out a 2 from each one of these terms. So this would really be 2 parentheses k squared minus 8k minus 20. So then this is something you can factor like we just did. Like what would multiply the -20, add up to -8, just because we're really low on time. It would be -10, +2. So like this would be 2k minus 10, k plus 2. So 12 is the same idea. Like I said, if you can pull out a GCF you want to, like this one, you could pull out a 5. So what would multiply to 6 and add up to -5? And if you don't need to write like your tree, like if you don't need to write your work, like if you can kind of see it in your head, like once you get better with these, some of you guys will be able to do that. Like, well, -3 and -2 would multiply the 6 and add up to -5. So, I'm sorry, my 2's look like my z's, so that's why I put the lines between them. But if you don't like for example, on your quiz, I don't need to see like you working it out, like with your tree. Like if you can just do it in your head, go straight to that factored form, that's perfectly fine. And honestly, that should be a goal. You should try and work towards being able to do that. But if you need to write it out, it doesn't bother me one bit. So these notes are on Google. I'm gonna post like after class, like and class is about to be over in like probably 20 seconds. I will post a Delta Math sections over greatest common factor and factor and trinomials when a is 1 if you want to try it tonight. If not, tomorrow we're gonna finish these notes and I will post like some more Delta Math like over the sections we covered.